Well, hello folks, it's Cliff here from Down Under. In this video I'm going to talk about the use of centers for machining in a lathe and a cylindrical grinder. So I'm going to be showing you machining up these spindles for ThreadExpress. I'll be machining them between centers, and you've probably seen in previous videos where they're held in a chuck at one end and a center is used at the other end for support. So I'll be covering that subject of machining between centers and the use of centers in this video. This video is going to be about machining parts between centers in a center lathe and in a cylindrical grinder. So I'm setting up the spindles to grind them on the old Brown and Sharp cylindrical grinder. You can see here both the centers are stationary, and that allows for very accurate machining. When the work is rotating between stationary centers, it allows for very accurate machining. And I'm going to be grinding this diameter on the end, this bearing diameter, and this bearing diameter down this end. You can do a similar procedure on a center lathe, of course, machining between centers on a center lathe. Cylindrical grinder has some benefits. It can grind hardened steel, it can work to very fine tolerances, and gives a very good surface finish. In the early days, decades ago, when I was getting started in contract tool making, I had this lathe back then in the 80s, and I would use a tool post grinder for doing cylindrical grinding, and before that I would use another method I'll show you in a second. So I would machine the parts usually with high-grade, high-speed steel and lap them, nowadays using a diamond lap to get an absolutely razor sharp edge there and take very light cuts. And you can machine to very fine tolerances between centers using high-speed steel. But if you find you're not holding accurate sizes, stop about 1/100th of a millimeter above size, or half a thou, and use this lapping method I'll show you in a second to take it down to the exact size. That's the first stage that I used for the first couple of years. Then I got a tool post grinder, and then I got a cylindrical grinder. Forgive me if you already know this process, but I'm sure there'll be one or two who don't. So you can do real precision finishing in a lathe. Put a rag down on the bed, get some wet and dry paper, say 400 grit, fold it in half, get a bit of ground bar, or a nice thick ruler if you don't have any, or a parallel, and running the lathe, see if I can just simulate it here, move it this way and move it lengthways. It's dipped in kerosene, and then just work your way backwards and forwards as you move it lengthways, using quite a bit of weight, holding it flat on the surface. And when you look at the underneath, you can see it's all grey with metal filings. Now that actually cuts very quickly, and you can lap down that last half a thou or 1/100th of a millimeter in a few minutes and get cylindrical grinding tolerances and surface finish by that method. Alright, let's go a little bit into centers. This will just be a quick overview. To cover the subject fully, you'd need a series of about 6 videos. Well, let's break them into 2 categories. So you've got fixed centers, which are low cost and quite simple, and the work in the tailstock revolves around the fixed center, and in a cylindrical grinder they usually are stationary also, and the work revolves around the center at both ends. And you've got rotating centers with their own little thrust bearings inside the rotating center. Now there's pros and cons with both systems. Rotating centers will take high thrust and they won't wear the center point as quickly because it's not rotating inside the work. The rotating part is inside the rotating center thrust bearings. So there's advantages there with rotating centers. They're really good for heavy duty lathe work, but they're often less precise because you've got another set of moving parts that are never perfect, and also they project further out from the tailstock and headstock, which also brings more projected inaccuracies and some less rigidity. Fixed centers are shorter and stubbier and are more accurate because there's less moving parts, but they don't handle wear as well because the work is usually rotating in the center, and that becomes a bearing. You need to make sure that it's well lubricated with high quality oil or high pressure greases, and they're fine for light work. So in simple terms, you use a fixed center for light machining, cylindrical grinding, finishing in a lathe, and you use a rotating center for roughing and heavy work in a lathe. There's all different styles of rotating centers. You can have cut down tips, which are great. They give you more access with your tooling. You can get in close to the end of the part, but somewhat at the expense of rigidity, and so you only use those when you have to. A plain center is a little more rigid. You can have rotating center sets that have different inserts that fit into a taper inside the rotating center, and that's really handy because you can, for a lower price, have a big range of centers. Here I made a holder for the same set of inserts. You can see there the taper on the end that goes down into the holder in either type of rotating center, and so I can use all of these inserts in my Brown and Sharp. This is a Brown and Sharp holder. So I'm just jumping backwards and forwards trying to cover the main points. With fixed centers, they're obviously low cost. That's a big advantage. So you can have a range of different shapes. See here, they're cut away at the end. That allows you to get in close with a grinding wheel. Obviously you can't cut it as far as the actual center, but for a very small center on that one, you can bring the grinding wheel really in close. And you can have little female centers for pointed parts. This one here is cut right away for a very tiny little center for grinding a very small diameter parts, for example, or very lightly loaded parts. You can have tungsten carbide tips on your centers. That way you have less problems with wear of your center compared with a plain hardened steel center. It can take higher RPM, but it still won't survive as well as a rotating center for heavy machining in a lathe. Nothing beats a rotating center for heavy duty cutting work because you've got much bigger thrust bearings doing the work for you. You can machine your own centers out of steel offcuts in your chuck. And then you've got a rotating center in the chuck. and that's really handy for large centers and for special angle centers. So that's a bit of an overview. You've got driving dogs, so this clamps around your work, and you have a pin coming out of your chuck or your headstock or a faceplate that drives the driving dog. As a set for my brown and sharp, I made one up here that allows you to grip down to very small diameters, and it hangs off the end of a part. See if I can show you. So it just grips, it just nips on one-handed operation here is never good, is it? If I can open that up, just trying to give you a rough idea. It just nips on the first couple of millimeters, and you can grind right up close to the end. So that's proven a very useful driving dog for cylindrical grinding work. Obviously for lathe work you need a much heavier duty driving dog, especially if you're taking big cuts, and you need to be able to stop it from slopping around with clamp screws on either side, or you hold your part in the chuck at one end, 3 or 4 jaw chuck at one end, and in a rotating center, for example, in the other end. You're sort of semi holding it between centers then, but half holding it between centers, and obviously it's not as accurate, but you get around the problem of driving the part. So it's very common to hold your work in a chuck and support the end with the center, sort of half machining between centers. Well, that's just a quick overview of centers. On a cylindrical grinder, machining between centers is very common, and they're usually set up really well for that because it's a high precision process. It's most accurate when the centers are stationary and the work revolves around the centers, for example in this brown and sharp. And that's because you have less moving parts with a stationary center, and you generate therefore more accuracy, all things being equal. The tailstock is usually spring loaded against the part. It may or may not be clamped after it's spring loaded. Loads are much lighter on a cylindrical grinder than on the lathe, so it suits machining between centers for several reasons. The loads are lighter and the accuracy requirements are higher. Cylindrical grinding is ideal for that situation. Here there's a little oil pot built into the tailstock. You can pull out a little dipstick and apply oil to your part quickly and easily before closing it between the centers. And finally grinding the 40mm diameter and shoulder. So I'm grinding the diameters that fit on the bearings. They're taper roller or angular contact bearings. This is the 25mm fit diameter. And I think the best way to go is just to make them a light sliding fit, very slightly tapered so they get slightly firmer as you go. And that's getting a little bit tight now there, but that allows you to assemble and disassemble it easily because it's a pretty lightly loaded little attachment. It's not like a lathe spindle. This is a very light attachment, and it means that it can be assembled and disassembled very easily. We could spray a bit of tacky rust inhibitor on those surfaces just to really lock them in, but the main thing that will hold them is that when the bearing preload is adjusted, you have frictional contact on the end faces of the bearings, so it's not essential to have interference fit on the diameters. So that's the final stage now, is just grinding these two diameters, 25 millimeters there and 40 millimeters down the other end. Of course, in reality, the diameter of bearings varies very slightly, and you may need to lap off a couple of microns to maintain that sliding fit. I'll try and remember to show you. It's very easy to do that on a center lathe. If your live center is an unusual size or angle, it often makes sense to machine it, and that way you know it is running true concentric. Just a reminder, when you're fitting bearings, that bearings often have a big radius on this corner that fits up against the shoulder. So don't put a big chamfer on your flange if you don't have a lot of land there, or you might run out of land for the bearing to sit up against. Machining between centers in a center lathe makes a lot of sense for certain shaped parts, particularly long parts with multiple diameters, because it allows you to machine multiple diameters all in the same setting, so they are all concentric. You might choose to machine a center down the live center end, attach some kind of a driving dog, and have a rotating center at the tailstock end. And then you can do really fine precision machining. I would use high-speed steel for the finishing cuts. So I started with high-speed steel and wet and dry lapping, and then a tool post grinder, and then one day back in the 80s I saw Ford Motor Company had this beautiful old brown and sharp cylindrical grinder coming up for tender, and all the way from Rhode Island, and I was able to pick that up for a good price. An absolute Rolls-Royce class machine, and ever since then I've had the joy of cylindrical grinding. But there's still plenty of times where lapping or tool post grinding on the lathe while it's set up is still the quickest, most convenient way to go. But when you're doing filing or stoning or lapping or honing work or polishing work on the lathe, make sure you always have a rag down on the bed. You don't want to be showering abrasive particles onto these surfaces and wearing a hollow in your lathe bed. Well, thanks for watching that video through to the end. If you found something useful there, please like, and if you're not already subscribed, please consider subscribing, and let me know your thoughts in the comments. And just checking you're aware that Mark Pressling has a channel where he is building a ThreadExpress currently. I'll try and remember to put a link in the description below so you can jump across to that and see how he's going. Cheers.